Hi all, Harvey here. Just wanted to do a quick video here of the negative before positive. Seems to be an issue, but just wanted to kind of clarify, a couple things. Very simple circuit. We just have a pulse generator. We have a 12-volt power supply, a couple of resistors to hold the capacitor value on one side up at 12-volt rail and down at ground on the other side. We have an input net label and an output net label. So we'll go ahead and run the simulator and see what we get. We've got this running for a full 60 seconds, so we can really compare how the output turns out. Up here we have our input, which is going from 0 volts up to 12 volts. The pulse is long, and then the off time is short, and that's what we want for this scenario. You'll see why in just a moment. You'll see this slope here is related to our capacitor value. We've got 33 microfarads on our capacitors, and so that's what that slope is we're seeing as that capacitor charges. And if we scroll over a little bit, we can see that our mean actually starts to drop below the 0 point. Switch to our output voltage, so you can see this is 0 right here. But as we keep going along there, we can see that it starts creeping up. And as it creeps up above 0, as we approach about 6 seconds into this, we're already above 0 here now on our waveform there. But it's reasonably flat across the top, even when we carry it all the way over here to 60 seconds. This is our average. But we're getting the negative before the positive. And a pretty good negative too, I might add, 12 volt negative on each one of the pulses. Now we can get rid of this leading slope here simply by reducing our capacitor values to say something like 10 microfarads. But in so doing, we end up with a scenario where the initial slope is taken up in just about one pulse width, but we get a little higher rise time on the return positive. So you can see that, and then once again it will ride up. Drag that across there. Here's 60 seconds. But not quite so much here on the end. So the lower the capacitance, the less riding we have at the end of the wave shape. And this is because we're pretty much charging the capacitor within a single pulse. So we could reduce that even further to say 1 microfarad for these values that we're using. And now we can see that we've got a really steep positive and a really steep negative. But again, the negative is before the positive. And this is caused because our input waveform is coming down before the positive. So if I was to change the offset on this and bring it down, say to 12, I believe that's the right direction. No, that was the wrong direction. Let's bring that down to 0. so we can see our timing on that. We'll just overlap them both at 0. And we can stretch that out a little bit. So now we can see that our pulse timing, as it drops, that's where we're getting that negative. And then as it climbs, that's where we get our positive. And the curve in between is part of the capacitance charge. Okay? So there's, well, doesn't really let me give you the whole screen. There's 50 seconds of that data. Separate these two. And that's what it looks like, with the negative before positive. Okay? We could put a diode in here and clamp the positive so it never really goes up. If we wanted to flatten that out, we could do all kinds of things. But this is a basic negative charge pump so that you can get those negative pulses and put them to use. Okay.